Welcome to Honors Physics Podcast. This is Chapter 7, Homework, question number 26 from the Putnell and Johnston. In this problem, we have a car and a van that are colliding elastically. The van is stopped at a stoplight, and the car is moving toward it with an initial speed of 2.25 meters per second. We know that the masses of the car and the van are given by the mass of the car being equal to 715 kilograms, and the mass of the van being equal to 1,055 kilograms. This is an elastic collision, it tells us, so after the collision, the van is moving most likely to the right with the van. And we're not quite sure what the car is doing. We can guess that because it's hitting a more massive object, it will likely bounce back in an elastic collision. But we're not 100% certain, so we need to find the final velocity of the car. The masses remain the same, and we are looking for the final velocities of both of them. So in this problem, we can see that both momentum is conserved as well as kinetic energy. And so we can use, because our initial velocity of the van is equal to 0, we can use the unique result that is found in equation 7.8a of our textbook. And that equation says that the final velocity of the moving object is equal to the difference in the masses divided by the sum of the masses times the initial velocity of the moving object. So if we were to adapt this to our particular case here, that means that the V final of the car is equal to the mass of the car minus the mass of the van divided by the mass of the car plus the mass of the van. As we plug in those values, we will have a 715 minus 1,055 here on the top, divided by 715 plus 1,055 on the bottom, and our initial velocity is 2.25 meters per second. We see initially that this top term right here, 715 minus 1,055, must be negative, and so we, admittedly, not surprisingly, see that the car does indeed bounce back, and the final velocity of the car ends up being 0.432 meters per second, opposite the initial direction, so we're doing this under here. And that's part A. To find part B, we're looking for the final velocity of the van. And we know that the initial velocity of the car, the final velocity of the car, and the final velocity of the van are all related to our momentum equation. Now you could also do this with the kinetic energy equation, but I would anticipate it being a more difficult equation to solve. So I say, as long as you're able to, take a look at this one here. Our initial momentum is the mass of the car times the initial velocity of the car, and that's going to equal the mass of the car times the final velocity of the car, plus the mass of the van times the final velocity of the van. As we plug all these things in, 715 here, 2.25 for our initial velocity of the van, or of the car rather. Mass of our car is still 715. Our final velocity is negative 0.432. And we will add that with 1,055 times our V final of the van. As you go through all of that, not terribly nitty-gritty algebra, you end up finding that the final velocity of the van is equal to 1.82 meters per second. And that's in the same direction as our initial velocity of the car, so it is to the right. So these two things come together, bounce, and the van moves to the right, the car moves to the left. This is question number 25 from Chapter 7.